So you done this job?
Yeah, what do you reckon?
The finish is good, but the threading is not acceptable.
Really? Why?
There's the chatter marks.
Yeah, I can see that. We knew that.
Because every time you machine this
It's a little bit rough on the top of the threads, isn't it?
when you machine
I'll polish it.
Yeah, you need to polish it. Because the customer will complain about the sharpness.
Well, I'm the customer.
No, you're at the moment you're not the boss, you are the machinist.
Oh, okay.
So you need to work efficiency.
Well, I thought I was.
No, you're not. You're going anywhere. That's good. The finish is good, except for the...
Yeah, well, I can easily fix that. I'll just go into the... I'll just go and polish this on the buff, all right? Yeah. Come with me. This used to be my favourite machine. This is when I bought this machine, I used to operate this and I used to love it. That was probably 15 years ago. So it's been a while since I've been on it. So I'm going to do this little project that Johari did in the last video. I'm going to see how I machine it, see if we're going to avoid the problems that he had and doing it. So I already see a problem with some of the parts of the machine. I don't like, you know, these T-nuts. Quite worn and damaged and really shouldn't be in the machine anymore. Plus the screws are quite flogged out as well because they use a rattle gun on it, which is fine, but they should really replace these screws every now and then. So this is potentially could be damaging to the chuck. If it's clamped down wrong, it could break the master jaws that are in there. So I kind of want to sort that out first. So we got a new set of T-nuts here, or newer, that I'm going to use instead. They're not as badly worn, and I'm going to throw these other ones out. So I've got a bit of 70mm diameter material, so I'm just going to use the hard jaws to hold it in the machine. Last hard jaws there. Okay. So I put the jaws in, so they're each numbered. So number three, they always go back into the same position. I just put it in at a starting point so I just look off the back of the jaw there and get them all into the same tooth step. About there. Just as a starting position. If my stop goes in, no, so I've got to come out a couple of teeth, probably a couple of teeth each. Okay, we can go in, so I clamp. All right, so I'm safe to lock them up there. Put my job in. And there's some little telltale marks on the master jaws and on the chuck. You can't really see in this light. But it gives you the distance travel that the chuck can do, and you need to be within those correct. If you're too far forward, or you might, if it's on the limit of its clamping, you might only be just clamping just enough, and you might think it's clamped, but it could throw the job once the tools start cutting. So there's more pressure on. So you got to watch for the little telltale to show you that you're in a good position. All right, my job is 90mm long. Stick out about 100, 105. My parting blade is 4mm. Well, actually, no, it's not. It's 3. I'll probably change that. I'll need to set some tools first. I've got a threading. I just need a parting blade that's a bit wider than that. I probably could use that. How far are we going to go? 25. I'll just stick with that. It's 2mm wide by the looks of it, and I think we're okay. All right. I'll just go with what we got. I'm only doing one part, so to get out at 100mm. I'm only using the top turret, so I'll just set my position on the front there. I'll bring my turning tool a little bit past, out there. I'll call that 0 there. My tool offset is close enough to 0. Soft stop is about there, so I can set that. If I go under parameters, I think I know where it is. Variable limits, calculate there. So my turret is not going to move back, you know, all the way to the back of the machine. I can soft stop it at that position. All my tools are going to clear, which is fine. All right, so now the program, if I can remember how to do it. I think we're in here. So I've got a new file, one touch IGF thing. I'll just say test parts. It's 4140. The OD of the material is 70 mil. Outside length is, we'll say 110, we'll give it a bit more. There's no internal diameter, there's no internal length. My Z is 1 mil, or 1 mil in from there, which is about roughly what I did on the job itself. Now I'll program the part. And this is where Johari went wrong. He took it as 30 degrees when it should have actually been 15 here, the other way. I'm going to go a bit further. We're going to part it off. Well, I'm going to put a parting line down it because I can't part off to full depth. And then I'm just going to bandsaw it off and then clean the back of it off. So now it's put each of the machining ops in, and then from here I can just adjust to how I like it to be. It's going to face down to the center first using tool 1, which is a WNMG. It's going to rough the OD fully with a tool number 2, which happens to be a DNMG. So there's a bit of a back angle on the DNMG cut, and it lets it go into this undercut behind the thread. Finish OD face, which is tool 3, so it's just going to face off the little bit there, which is left. Finish the OD. Thread. So I'm just going to, at the moment it's selected on the bottom turret, so I'm just going to shift that to the top turret because I'm not going to use the bottom at all. And that's it. We're done. I'm just going to check this threading, make sure it's travelling to the Z. It's going to minus 27. Our shoulder back here is 35. So if and I think we touched off the front of the tool hole, off the threading bar usually. So if I've said minus 32 there, there's plenty of overrun into the undercut. So I can process test, put in high speed. Finishing, threading. That's it. So even though it hasn't parted off, I'm just going to take it out of the machine, bandsaw that off, and finish the back edge. And there's a problem because I've set my data wrong. So in the program, I knew I had it the wrong way around. So what I'm going to do is shape the time, modify. I think it's in here. Going quick, hold around. Basic blank. I think I need to put 109 here as well. 109. Let's try that again. So that's the facing. Tool number 2 is the roughing OD. Just turn the water off. Not anything, that looks good. Okay, we're safe to go. You can see there. I'm used to this machine probably a lot more, you know, because I did a few years on this one. I think Johari may have been overthinking a little bit, which is fine. It's always better to think about what you're doing than just go in blindly. But this is a very simple program. Everything's cut from one side, you know, once you've done the extremities of the tool, so it's not going to hit. Like when I just watched where that tool number 1 tool was going, I know in the program it's not going to, nothing's going to travel any further than that and hit the chuck. So I'm pretty safe with that. The only thing I'm probably going to do now is just check my diameters to see if if the tools, because I didn't check the tools. I'm just trusting that they're set at the correct as what they were before. Which I don't like these micrometers, they're crap. I'm going to get a new one. So I've got a diameter of 25. This should read 25.4, roughly. It's 25.6, so we're oversized, so I'm going to have to come down. I'd say the finishing tool will be set above as well. I'm going to take a risk that they're set right. So I'm just going to continue. Actually, I'm just going to stop it there. Just double check that. That should cut at 25. Before I do the other diameters, I'm stopping on the thread because the OD of the thread is not as critical as the other dimension over here. So that's still above. So we're 0.1 above on what I programmed, so I'm safe to run that. Now let's see if I can remember how to do a restart. Main program restart, NATO3. So that'll find where tool number 3 is, and I think it was sequence restart. I was okay with that. So I can start my operation at tool number 3, which is the finishing tool. So it's just going to do it's just going to face again and stop because I've got optional stop after each process. So now we're doing the diameter again. I'm going to recheck my diameters, compensate. Let's turn the water back on. Compensate, and go from there. Okay, next tool is tool 12. So my speeds and feeds look good. The finish is reasonable. I need to check that diameter, 45. So we're actually 45.16, and we need to be on the high side, 45, which is 03. So if I take 0.1 off now, I should be starting to get them close. Okay, so I go to my tool offsets. Where are they? Tool number 3, add minus point. Let's go 0.08 to begin with, just in case there is on the right spot. Yeah. Aim for a restart. NATO3. Okay. Sequence restart. Yes. Cycle start. So I'm just bringing down the diameters. I'm just not taking the full amount off, just in case there's any spring cut left in the job. You got to watch out for that. Sometimes, you know, if you've got 0.1 to come off and you program it to cut 1 point, it might cut a little bit more. You might end up undersized if you're on a very close tolerance. So sometimes it's a good idea to just bring it down gently to diameter. Okay, so that didn't do much at all. So I've got another, if I set another 0.5 to come off, I'm going to be safe. So I just go back into my tool offset, which is this button here, add minus 0.05, I rerun again, and restart. It's ready to start threading. I'll just measure again. Okay, we're kind of spot on size, spot on top tolerance, so I'm happy with that. Now I continue with the threading. Just making sure that this is, and there we go. So that's the threading cycle going through now. A little bit of vibration. And this is the parting. I'm not going to bother checking the. It's the same process. So you measure the threads. You check how much has got to come off. You take it off the tool offset until you get it down to size. Similar to what I did with the 45 diameter here. So now I'm just going to go straight into the parting cycle. I'm just going to double check nothing is interfering with chucks anywhere. That looks all right. Coolant. So this is more of a grooving blade rather than a parting blade, so I don't have the reach to reach all the way to the center. I could have put a new tool in, but for the sake of the time and getting this job done, I'm just going to leave it like that. So there's the groove gone in. Let's put the chamfer on this face as well, on this side. My thread is looks all right, and that's it. It's job done, so I'll put it off. Obviously, if this was a production of you wouldn't be doing it, but since it's only a one-off, this is the most economical way to do it. And the blade is no good. Let's go for option 2. Let's part it off with a grooving tool. Hopefully I've got one. It's going to get me close. Just. Is there coolant in the machine? No. Come on. Give me some coolant. No. Never mind. We'll work with what we got. Oh, not quite enough there. We've got about 10 mil to cut off. I think the bandsaw can manage that bit. There we go. Face the back off. Try not to damage that diameter. A bit faster. Coming back. All right, job done. And I can check some diameters and lengths as well, but I'm pretty confident that's all pretty good. A little bit of chatter on the thread on the front. That can be improved by speeds and feeds. And there you go. So we can polish the thread and polish the front and take any sharp edges and burrs off. And the back as well. What about now? Is that all right now? Is that all right, boss?
Much better. They won't complain.
No? Okay. Well, I'm going to do the next one on the manual now as an exercise. See how long that takes me.
Okay, let's see if the #1 WA machinist can do it the manual.
I think I'll get you to do it on the manual.
I'll be the supervisor.
All right. Let's do one on the manual, eh?
Yeah.
I'm not looking forward to it.